Let's start with the next unit, that is discrete Fourier transform. In the last unit we see discrete time Fourier transform. Let's suppose we have a signal x of t. We know that the CTFT of that signal is represented by x of omega, that is frequency domain. Similarly, if we sample the signal xt, that we get x of n, and if we find the DTFT of the signal, that we get again x of omega. We know that the x of omega is continuous and periodic in the case of DTFT with a period of t, where omega represent as 2 pi f or 2 pi by capital T. Now we know that our requirement is the discrete signal. Now we will go for the sampling of x of omega. Now we know that if we go for the sampling of x of omega, we in the duration of 2 pi, and the signal varies from 0 to n minus 1, or you can say that of duration n, we take k samples, and the difference between each sample is represented by 2 pi by n, because total period is 2 pi and samples are from 0 to n. So each sample having space with other one with the 2 pi of n. So x of omega having k sample is represented by x of k. Now DFT, discrete Fourier transform of xn, is given by x of k, which is represented by x of k is equals to summation n varies from 0 to n minus 1 xn e raised to power minus j 2 pi by n into k into n, where omega is now 2 pi by n into k, because we take the k samples, and n varies from 0 to n minus 1. After that it repeat itself. Okay, take care of this thing. And the IDFT is represented as x of n. X of k will be given, x of n is equals to 1 by n. X of k, k varies from 0 to n minus 1 e raised to power j 2 pi n k n. DFT is nothing but the Fourier transform of sample signal which repeated periodically, and the number of points in the DFT is known as n point DFT. Let's go for the first question, where x of n is equals to 1, 2, 3, 4, and the 0th position is on 1. We have to find out the DFT. Okay, just by seeing the equation we come to know that we have to calculate 4-point DFT, where n varies from 0 to 3, that is 4, and k also varies from 0 to 3. So x of k, formula of DFT is 0 to n minus 1, that is 0 to 3 xn e raised to power minus j 2 pi by n. N is 4, k into n. Now we have to find out the values at k is equals to 0, k is equals to 1, k is equals to 2 and 3, that is x0, x1, x2 and x3. For each and every value of k, n varies from 0 to 3. Open the summation, x0 xn e raised to power 0 for k is equals to 0. So it is x of 0 plus x of 1 plus x of 2 plus x of 3, that is 1 plus 2 plus 3 plus 4, that is 10. For k is equals to 1, we have x of n e raised to power minus j 2 pi by 4 into 1 into n. Now put out the value of n over the summation, 0 to 3. So we will get 1 plus 2 e raised to power minus j pi by 2, which is equals to minus j. So similarly we solve the equation and we will get 1 plus minus 2j plus minus 3 plus 4j, that is minus 2 minus 2j. In the similar way we will find out the value of x of 2 and x of 3. So we will get x of 2 is minus 2 and x of 3 is 2 minus 2j. So final answer for 4-point DFT is x of k is represented as 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Take care of this is that x of 1 and x of 3 will always be the conjugate pair. That is the property of DFT. Now second question, x of n is equals to 1 by 3, where n varies from 0 to 2. So by seeing the equation we can say that here n is equals to 3, k is equals to 3, that is 0 to 2. So we will find out 3-point DFT. X of 0 is equals to 0 to 2 n, x of n e raised to power 0, that is, open the summation, we will get 1. Similarly we will find the value of k is equals to 1, that is x of 1, and k is equals to 2, x of 2. Now if for the last question, if we have to say 4-point DFT we have to find out, so then in that case we have to insert one sample. Take care of this thing, that is x of n is equals to 1 by 3, 1 by 3, 1 by 3. Similarly fourth point we have to calculate 4-point DFT. Fourth sample is not there, we have to pad 0. that is padding of 0 or insertion of zeros. Okay, so simply we have now 4 points. N is equals to 4, k is equals to 4, that n varies from 0 to 4 or 0 to 3, sorry, 0 to 3 xn e raised to power minus j 2 pi by n. N is 4, k into n. Open the value of put the value of k and n, and we find out the values of x0, 1, 2 and 3. Now this is the one way for calculating DFT. We have another way, that is DFT as linear transformation. Now e raised to power minus j 2 pi n by 2 pi by n into kn, we can write out this equation, this term as wn kn, where wn is named as Twiddle factor. Like wn e raised to power minus j 2 pi by n is equals to e raised to power minus j whole raised to power 1 by n, where we know that e raised to power minus j 2 pi is 1 raised to power 1 by n, that is nth root of unity, or we named as Twiddle factor. Okay, now we know that for n is equals to 4, w40, w41, w42 and w43, we have to find out the values of this. W40 is equals to 1, w41 is equals to minus j, w42 is equals to minus 1 and w43 is equals to plus j. Why we calculate this value? Just see that we know that TFT can be represented as n is equals to 0 to n minus 1 xn wn kn, where wn is e raised to power minus j 2 pi by n. Okay, so put out the value of k. X of 0 is equals to x0 wn0, x1 wn0 plus x2 wn0 and so on up to xn minus 1 wn0. Put out the value of k is equals to 1. Open the summation. Similarly, we put out the value of k as n minus 1. So we will get first row and first column as wn0 and its value is 1 and multiply by x0. So we can convert this equation into the matrix form. See the matrix on the right hand side. So it will be 1 and 1 in each first row and first column multiplied by the x0. Similarly, second row x0 wn0, that is 1 multiplied by x0, x1 multiplied by wn1. So second factor in the first matrix is wn1, x1, x2, x3, xn minus 1, and this first matrix that is named as Twiddle matrix will be of order n by n. On the basis of this, we will solve the question also. Now n is equals to 4, so x of 4 is equals to x0, x1, x2, x3. This matrix will convert to the 4 by 4, that is 1 1 1 1 on first row and first column, w41, w42, w43. Similarly, third row w42, 4 6 3 6 9 multiplied by the matrix of order 1 by 4 x0, x1, x2, x3, which is given to us. Okay, now w46 can be written as w44 plus 2, and we know that w44 is 1, so it is similar to the w42. w49 will be equals to w41. Solve this question. Xn is equals to 1 2 3 4 by using DFT as a linear transformation. We know that this matrix can be represented as 4 by 4 order, first row as 1, first row column as 1. So w41 minus j, w42 minus 1, w43 j, w42 minus 1, w44 1, w46 minus 1. Similarly, we can put out the value and multiply these brackets of order 4 by 4 and 1 by 4. We will get 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. Again, x of 1 and x of 3 is conjugate pair. By using DFT as a linear transformation or open the summation, we will get the same answer.